This lesson is for Mrs. Cucci's College Now College Prep class. We are at the beginning of Unit 3 on Lesson 3.1, and we're going to be talking about algebraic functions and formulas today. So if you want to have these notes out in front of you, make sure you get everything down. So the first thing we need to talk about is what an algebraic expression actually is. An algebraic expression is a combination of variables and numbers using operations like addition, subtraction, multiplication, and division, as well as powers to be kind of put all together. Okay, so let's just put that in here. So when we start talking about evaluating algebraic expressions, or finding the value of an expression for a given value of a variable, we start to think in terms of the order of operations. Now, you guys have done order of operations since elementary school, and you're probably more comfortable seeing it as PEMDAS. Okay, so this is just saying how we actually simplify these algebraic expressions out or perform them. First, you're going to take care of whatever's inside parentheses. Then you're going to go to your exponential expressions. Multiplication or division, it doesn't matter which one you do first, you're just going to work left to right. And then addition or subtraction, again working from left to right. So let's take look at an example of an algebraic expression, and we're going to evaluate it. So this problem says evaluate 7 plus 5 times the quantity x minus 4 cubed for x equals 6. So what this means is I want to take x, and instead of writing x, I'm going to write in 6. So we're substituting in the value of 6 for x. Okay, so once we're here, we're going to follow our order of operations. So first thing we need to handle is parentheses. Okay, so we're going to do what's inside my parentheses. This is supposed to be addition sign, sorry about that. So 6 minus 4 is what's in my parentheses. So I'm going to go ahead and multiply that, or subtract that. Then the next step in order of operations is exponents. So if you see here, I have 2 raised to the 3rd power, so I need to handle that next. 2 cubed is 8. Then we're going to move on to multiplication and division. And as you see, we've got multiplication here. So we're going to go ahead and do that multiplication. And then lastly, we're going to add. So when we evaluate this algebraic expression for when x equals 6, it evaluates to be 47. Okay, so let's try another one. We're going to evaluate the algebraic expression x squared plus 5x minus 3 for x equals negative 6. So our first step is to go ahead and do that substitution. Now, since the value is negative and I am squaring it, I want to make sure that that negative 6 goes in parentheses, because I'm actually going to want to square the negative 6, and there is a difference between this and this. Okay, this says negative 1 times 6 squared, whereas this says negative 6 squared. So you have to be cautious with that. Plus 5 times negative 6. Notice I'm using parentheses here. Minus 3. Okay, so we're going to start with what's inside parentheses. So if we look here, there's nothing we can do inside the parentheses. So we're going to move on to our next order of operations, and that's exponents. So negative 6 squared. Well, negative 6 squared means I have to multiply negative 6 by itself. Negative 6 times negative 6 is a positive 36. And I'm going to bring everything else with it. Moving on to multiplication, I've got multiplication right here. So 36, 5 times a negative 6 is a negative 30. And then addition or subtraction, as you can see, I've got subtraction, and I'm going to work left to right. So 36 minus 30 gives me 6. 6 minus 3 gives me 3. Okay. Let's go to the next example. So now we're getting a little bit harder, and we're looking at evaluating an algebraic expression with 2 different variables. It's done the same way. We're still using substitution, but we have to be careful where we're substituting things in. X is going to be 4, and y is going to be negative 2. So we're going to go ahead and substitute. 2x is 4 squared plus 5 times x, which is 4, times y, which is negative 2. minus y, which is negative 2 cubed. Okay, again, order of operations. Starting with what's inside of the parentheses. So if I look inside parentheses, 4, 4, negative 2, negative 2, there's nothing I can do inside of them. So I move on to the next one, which is exponents. And I do have a few of those. So I've got my first set of exponents here. I've got 4 squared, which is 16. I keep bringing everything with it. And then negative 2 cubed. So negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is positive 4. Times negative 2 is negative 8. So minus a negative 8. Okay. And you guys already know that when you have minus and negative, it simply becomes plus. Right, and I don't really need the second one, obviously, but it was there from changing it. So now we're on to multiplication. Negative 2 times 16 is negative 32. Plus 5 times 4, which is 20, times negative 2 is negative 40. Plus 8. And then we're going to go to addition, subtraction, moving left to right. Negative 32 plus a negative 40. Okay, so you're adding two negative numbers, which means you add them together and keep that negative sign. So this becomes negative 72 plus 8. Negative 72 plus 8. So if I owe somebody negative $72 and I give them 8, how much more did I owe them? Negative 64. Okay. So let's move on to formulas and mathematical models. Now, an equation is formed when an equal sign is placed between two algebraic expressions. Excuse my shorthand. Okay, it's formed when you have an equal sign between two expressions, but we were just working with those were expressions. A formula is an equation that uses variables. Oops. To express a relationship between two or more quantities. So an example of a formula could be H equals 1/5 220 minus A. Okay, H perhaps being heart rate per in beats per minute, and A being your age, difference in age. Okay, so there's two different variables working together there. Okay, so let's talk about modeling caloric needs. So we're going to work with a word problem here and figure some things out. Bar graph below shows the estimated number of calories per day needed to maintain energy balance for various gender and age groups for moderately active lifestyles. Moderately active meaning a lifestyle that includes physical activity equivalent to walking about 1.5 miles to 3 miles per day at 3 to 4 miles per hour, in addition to light physical activity associated with typical day-to-day life. Okay, so we're going to be using that bar graph to now answer some questions. Okay, so we've got a mathematical model. So basically we have a formula that was built using this data here. Okay, we're going to use the mathematical model to answer the questions below. So it describes the number of calories needed per day, right here. Number of calories you need per day is W. By women in age group X, so whatever your age group is goes here, with moderately active lifestyles. According to the model, how many calories per day are needed by women between the ages of 19 and 30, inclusive? So including 19 and 30 with this lifestyle. Does this underestimate or overestimate the number shown by the graph? And if so, by how much? Okay, so let's do the first part here. So I want to know how many calories per day are needed by women between the ages of 19 and 30, inclusive with their lifestyle. So we're going between 19 and 30 years old. So I'm going to go back up, and I'm going to look at age group 19 through 30. Okay, so here's 19 through 30. And it's been deemed group 4. Okay, group 4 is 19 through 30. So that's the group value for X that we're going to be plugging in. All right, so I want to know how many calories. So W equals negative 66. And I'm going to be putting in 4 for the group value, squared plus 526 times 4 plus 1,030. So now I'm going to go ahead and evaluate this. Negative 66 times 16, exponents first. Okay, multiplication next. And now straight to addition. Negative 1,056 plus 2,014 plus 1,030 is going to give me 2,078. Okay. So we're saying we need 2,078 calories per day, according to our formula, right? So that was 1. Question number 2 says, does this underestimate or overestimate the number shown on the graph? So let's go and take a look at group 4. We're saying 2,078. Okay. For group 4, we're saying that women, so in the red, 19 to 30, women are about here. Okay, just above 2,000. So it looks to be about 2,100. All right. So were we have an overestimation or an underestimation? The mathematical model underestimates the caloric needs of the women. So it gave us 2,100, right? So it underestimated. It's lower. By how much? We need to do the subtraction to figure that out. And this gives us 22 calories per day. That's my underestimation. Okay. All right, so we have some vocab words that you absolutely need to know. So we're going to go over those real quick. Okay. So the first one is terms. Terms of an algebraic expression are the parts that are separated by addition or subtraction. So if I gave you 7x minus 9y minus 3, 7x is a term, negative 9y is a term, and negative 3 is a term. Okay, there's 3 terms. Coefficient. A coefficient is the numerical part of the term. So if I have 7x, 7 is the coefficient. Constant. So that's just the number, just a number. So negative 3 would be the constant. Doesn't have a variable attached to it. Factors are the parts of the term that are multiplied. Okay, so if I have 7x, 7 is a factor and x is a factor. because they're multiplied together. Like terms have the same variable. Okay, so that's just some vocab that you need to be comfortable with. Okay, so properties of real numbers, this is something that you've been doing for a really long time. So we're going to move kind of quick through this and just give you basic examples. Commutative property of addition would be a plus b equals b plus a. So essentially they're just switching positions. Commutative property of multiplication, same type of thing. X times 6 would be equal to 6 times x. Okay. Associative property of addition. Let's say I have, or I'm sorry, this should be AB equals BA, either way. A plus B plus C equals A plus B plus C. So if you notice the associative property, it's changing where your parentheses are. It's changing what it's grouping. Same thing with associative property of multiplication. If I had AB times C, this would be the same thing as A times BC. It's just changing what's being grouped. And distributive property. If I had AB plus C, that's going to be equal to AB plus AC, distributing. Okay. As well as AB minus C, same thing here, AB minus AC. So again, these are our review. You guys have been doing these forever. All right, so let's move on to some combining like terms. Okay. And again, you've done these before too, so this is going to be a review. So if we're looking at this, we're going to start by trying to get rid of those parentheses and using one of the properties that we had above, which is the distributive property. So we're going to go ahead and distribute here. 5 times 3x is 15x. 5 times negative 7 is negative 35. And then we leave that minus 6x on the end. From there, we want to go and we want to combine like terms. So like terms have the same variable, right? So if I have negative 15x, I have a like term of negative 6x. So combining those, all I have to do is add or subtract the coefficients. 15 minus 6, okay, which is 9x. And then since that negative 35 doesn't have a like term, I'm going to leave it. So 9x minus 35. All right, let's try another one. So it looks like I'm going to have to actually go and distribute twice here. So we're going to go ahead and do that. Get rid of these parentheses. 12x squared plus 24x plus 40x squared plus 30x. Now I find my like terms. Remember, it has to have the same variable, so those variables have to have the same exponents. I've got 12x squared, and I have positive 40x squared. Okay. Now, I also have positive 24x and positive 30x. So I have to make sure that I combine the like terms. 12x squared plus 40x squared is 52x squared. And then 24x plus 30x is positive 54x. Okay, you don't change the exponent on the variable, you leave it. You're just adding or subtracting the coefficients. One more here. So remember, order operations always tells you to start inside the parentheses, as far in as you can get. So you have kind of two sets of parentheses here. Can't do anything here, but we can do something here. So basically what this is showing me is there's a negative 1 here. So you need to distribute through that negative 1. So negative 1 times x is negative x. Negative 1 times negative 3 is positive 3. Keep working inside these parentheses, and we're going to combine some like terms. We have 5 plus 3, which is 8 minus x. Now we can go and we can distribute 8x plus 16 minus 2x. And now we can combine those like terms. 8x minus 2x, 6x plus 16. Okay, so make sure that you do the practice document after this, and then be ready for lesson 3.2 tomorrow.